Now, the next very important topic that we need to know from chapter number 1 is logical binary shift. And for that, the very first term that we need to know is left shift and right shift. When left shift is being done, it means that the values which are present on the left hand side or the bits on the left hand side are going to be moving out of the byte, and they will every single bit shifted means that if, for example, if there is one shift being done, so this bit on position number 128 will be moving out of the byte, and the value that is present on position 64 will come and replace this position. In this manner, every bit will be shifting one place to the left in case of one left shift. And what else you need to know is the left shift results in loss of most significant bit or MSB. Another important thing that you need to know is the resulting value is going to be multiplied. Like one shift means multiplication by 2, two shift means multiplication by 4, three shift means multiplication by 8, and in this manner the values are there. But just remember one important thing. In case the values lost are zeros, the result will be multiplied properly. But the moment you are losing a 1, then it means that the result will be a wrong answer. So please be very cautious about the questions that are coming for logical shift. It's not always like that. Sometimes you are prompted that they're asking you that what happens, and with this what happens, they want you to tell that this with this what happens, is it resulting in the proper multiplication? Like if the values that are lost, like in this case, if I say till the time I am shifting 2 bits, that will be the perfect answer. But the moment if it says shift 3 places, it means that if I'm losing this value, the value is a 1. So it may not give you the right answer, but it will not give you the right answer. So be very cautious that till the time that you are losing a 0, that's perfectly okay. But the moment you start losing a 1, then the answer will be incorrect. Are we all clear? Left shift means multiplication and right shift means division. One shift means multiplication by 2, two shift means multiplication by 4, three shift means by 8. In this manner, you can keep on working like 2 power 1, 0, 2 power 1, 2 power 2. In this manner, you can recall and remember. Moving to the right shift, if I talk about this right shift, in case I'm talking about the right shift, means this value is lost. Till the time this 0 is lost, that's perfectly okay. It will be division. So just simple principle. Let me talk about this simple principle. Till the time you are losing a 0, that's perfectly okay. Again, the same thing that we do. You are going to move the bit out of the byte, and all the bits will be moving to their right hand side. That is why it is called a right shift, because every bit will be moving towards the right hand side, and the empty space will be again padded with a 0. And remember, this not this 0. Please be very clear, because if they ask you to explain how this shifting is being done, then you should be very clearly answering that how the shifting is being done and what is happening. With left shift, it's MSB lost or more significant being lost, and with right shift, it's LSB only significant being lost. Second thing is, till the time you are losing a 0, the answers will be accurately giving you multiplication or division. But the moment you start losing a 1, the answer will be incorrect. So are you clear about this shifting completely? Yes, children. Any questions regarding shifting of the logical binary shift or the logical left shift or logical right shift? Any questions before we proceed to the next one? Okay, now there are a few activities which you can do, and then you can figure out yourself that whether your answers are right or wrong. Now, another very important topic that I really want you people to remember is the two's complement. Now, be very clear. Two's complement is simply meant to handle the signed values. I say signed. With signed, I mean the negative or the positive. So if you get a question that deals with a positive value, a positive integer value, which is going to be storing the data in two's complement, then remember the technique is very simple. You assume that number to be a simple number. Like if it is plus 5, so you will not do any sort of the two's complement technique that you have done till now. You will simply find out the boundary for 5, and you will put them in the respective positions, and the answer will be correct one. So just remember, the moment you have two's complement, then the chain that occurs in the byte is this value becomes the sign bit. And this is going to hold a value minus 128. This minus 128 or the sign bit or the MSB will be a 1 in case the number is a negative number, and this MSB will be a 0 in case the number is a positive number. That is the indication. Like for example, you can see for yourself, they have given two examples and the example is minus 128 here. It means it is minus 128. So minus 128 plus 64 plus 32 plus 4 plus 2, and that gives you minus 26. And the same, the only change, as you can see here, all the values are the same, but the only change is the value 0. So just because of this 0, you can see it is a positive number. That's why 64 plus 32 plus 4 plus 2 will be giving you the value of 102. I'm specifically telling you because this is what the students normally make a mistake in. Be very clear. If they have given you any positive value and they are saying that store it in 2's complement, then you will assume that it is the same as normal denary to binary conversion, and you will simply do the same process as you are doing. You will simply put the 0 here and the rest of the process remains the same. Another chain that you need to remember, let me write it down for you so that you can note it down. If I say a byte, in a byte, the smallest value is a 0 and the largest value is 255. But when it comes to a 2's complement thing, the same value will change. Now, in 2's complement, what happens? The capacity of the byte, or you can say the whatever is stored in the byte will change, and now the value will be from minus 128 to plus 127. This is again that can come in the paper. So plus be very, very clear about this. Better write down the values that you will remember that in case of 2's complement, the capacity of the byte will change. The byte will now be holding from minus 128 to plus 127. Similarly for a nibble, if I say a nibble is holding from 0 to 15, isn't it? I think this is what we have already talked about. And we know also. But when it comes to 2's complement, the change will be, now you can see the same thing, the same concept. This will become, like if I just talk about this will become minus 8. So the capacity of the nibble is going to be from minus 8 to plus 7. Are we clear about this? These kind of questions can come as 1 mark, 2 mark questions. So please be clear. The capacity of the byte in case of normal is 0 to 255. When it comes to 2's complement, it is minus 120 to plus 127. In a nibble, the smallest value is from 0 to 15. And then it will be from minus 8 to plus 7 in case of a nibble, which is 2's complement. Questions can come in what manner? First question is just the same, denary to binary conversion, and sometimes it can give you a binary value to be converted to denary. So whenever the 2's complement word is written, so you will apply the same process as I showed you right now. Just treat this number as minus 128 and then you will do the rest of the conversions. You will keep the rest of the values in the same manner and you will find out the answer. It means it is a negative value. Same process here, the value is a 0, so it means it is a positive number and you will do the same process and this is your final answer. Second question is you are given a denary value to be converted to binary. So this is like, for example, if they say that it is maybe minus 67. So in that case, what will you do? You will simply do it in two ways. Actually, by the way, just remember, this is the normal way that you need to know. The better way to know, that you need to know is if they're asking you to convert minus 67 to its equivalent binary value using 2's complement, it means the first step is you will simply find the binary of the normal number, ignoring the sign. That is, for example, if it's 67, you will turn on 64 and then you can see for yourself 64 and 2 and 1 that is turned on, and 64, 65, 66 and 67. Then you will flip the bits. Flip the bits means all the zeros become 1 and all the ones become 0. 1, 0 becomes a 1, 1 becomes a 0, 0 becomes a 1, 0 becomes a 1, 0 becomes a 1, 0 becomes a 1, 1 is 0 and 1 is 0. Then you will add 1. And when you add 1, then you can see this is the simple addition process that we have learned. 0 plus 1 are 1, 0, 1, 1, 1, 1, 0 and 1. Again, a suggestion, when you are getting such a question in the paper, always just redo so that you can be happy that whether your answer is right or wrong. I mean, it will hardly take you a minute. Just for the purpose of verification, you can do it so that you are happy that your answer is correct. Now, just one, I hope that there is no confusion till now. All the questions are understood by everyone. Now there is sample questions and answers. You can do these sample questions and answers, but what I really want you to do is they are suggesting you some tips, and I keep on suggesting you also. Whenever you get a question like this, they are giving you working space. Always utilize the working space, because it may happen that when you are doing the work, that maybe the working is done accurately, but when it comes to writing the answer, you have made a mistake. So if you have done something correctly in the working space and your answer written is wrong, still the examiner may give you marks. So this is what they keep on telling you. Always write. And another thing is, always write down, even if you know it. I know that you know it. I mean, we have been doing it, and we all know that 1 2 4 8 16 32 64 128. We all know nibble is A1248. But still, again, a sincere advice, always write it, so that the examiner knows that you know the right procedure. So this is the main thing, that my objective is to make you understand these tips that you need to apply, because exams are hardly a month away. So you need to apply these tips in your papers. First thing is, you need to write down the value. Second thing is, you need to use the working space properly, so that you are never you're on the safe side. Okay, now another important thing is the use of sample high level answers and sample low level answers. Definitely, I'm not expecting that any of us will be ever moving to the sample low level answers, but just to tell you that sometimes the students do make such certain things. See, this is the same question which is attempted by two students, and one student's work is considered to be a high level answer, and another one is considered to be a low level answer. And reason, there you can see the first student has explained very well, and they've used the 8-bit binary format, the 8-bit word format, and they are doing everything in a proper manner. So they've just taken the answer script answers from the student's question, and they are mentioning these as the high level answers, because what the child has done, you can see for yourself. And definitely, we really want all of us to follow the same high level answer pattern, so we are always gaining very good marks. So I hope that there's no confusion. But again, I suggest you people to attempt these activities also, which are given here as sample questions and answers for yourself. You can go through this yourself, like it's this simply conversion, then carrying out a shift on the same value, and then you can see, comment on your answer. This is what I want you to concentrate on. You all know how to convert a 44 to its equivalent 8-bit binary. You all know the shifting of two places. You all know the shifting of two places, right? And then comment. Now, what is the difference between the two comments, the high level comment and the low level comment? So let me show it to you. Then again, you can see at now, this is what that can come in the paper. You are given one binary value, all conversions done, all the process done, and then you are given another binary value to be another binary value to be like another denary to be converted to binary, and adding that new value to the previous value. So please be clear, and then again commenting. Maybe there's some overflow error. So you need to answer, and let's see what the best answer was and why that answer was the best answer. So this is why the answer was the best answer. Let's talk about, this is equivalent to this. The child has written the answer for the shifting. Shifting two places left should give the result 176, which means the actual result is the same as the expected result. So when you talk about shifting, fine, a student was asked to comment. So what one student can simply say, fine, shifting done, fine, perfect. He simply wrote the answer, and the work was done. Another child did what? He has explained it very well. And what he did, he simply said that I have performed this thing. The result is this one, and it is equivalent to the original value. Like 44 was the original binary value, was the original binary value to be converted to binary, and you can see for yourself, this is 44 into 4, and that is 176, means your answer is actually correct. But in case it's the loss of one, the child must have written that since there is a loss of one value, the loss of one from the byte, it may not result in the complete binary value, in the right binary value. Again, for the right shifting, you can see what is the comment. The binary number is 220. Adding this to no, this is the one. This is equivalent to 8 plus 2 plus 1, 11. Shifting two places right should give result 44 divided by 4, that is 11, which means the actual result is the same as the expected result. So this is a good answer, a high level answer. Commenting, describing. So whenever a questions of description are coming in the paper, asking you to comment on your answer, then this is what they expect you to write in your answers. So any questions? And when we have done this activity again, you can see that again another example of a high level answer for addition of two binary values, and the result is going beyond. Again, what the child has written. Expected result is 264. However, the value is generated. The value 8 is generated. This is clearly indicating that it is a wrong answer. And it is because it is going beyond the capacity of the 8-bit word, that is 255, and an overflow error has occurred. So just properly describing will give you the marks and the high level answers, and the examiners will be definitely very happy with your answers. And I don't want to show you the low level answer at all. You can see for yourself that it's completely, I mean, you yourself will not like these answers at all. See, this is what the child has written. He has simply he has simply written the answer like this, and he has not commented at all. He had done, but he has not done the commenting. That is what is going to be considered as a, you can see again, just second student has used the correct conversion in parts A and B, but they have written the binary numbers in the wrong order. And the answer is not in 8-bit binary format. Be clear, in 8-bit binary format. Answer is incorrect since they haven't added extra zeros. They could have gained a follow-through mark from part A if they have added the extra two zeros here. Part C would gain a follow-through mark since this time the additional zeros were added. Part E is completely wrong. Probably 2 or 3 marks will be given out of 9. So see for yourself how easily you can score and how easily you can lose the marks also. So I think there is no problem in comprehending, and then again a practice exam style questions are here for you. You can do them and then you can share the answers in case of any problem. Another very important topic of this chapter number 1 is your text sound and images. And in this, what you need to know is the term character set. And then what you need to know is ASCII value and Unicode. Difference between the two, I hope that we remember. ASCII is storing the values, the character values in 7 bits. Excellent ASCII is storing the same value in 8 bits, and it can store up to 256 values, 0 to 255, because it is 8 bits. And Unicode is supporting non-Western languages. Unicode is supporting emojis also, and Unicode is storing the data in 32 bits or up to 32. It's 16 also, like for you people, but maximum is 4 bytes per character. So if a question comes in the paper asking you to differentiate between the two sets, then this is what you will mention, that ASCII is supporting Western language characters only. And it is storing the data in 8 bits maximum, 7 to 8 bits, while Unicode is supporting non-Western languages. It is supporting the emojis also, and it is using 32 bits per character. So I hope that this will definitely give you enough marks. One question that hasn't come yet but may come in the paper is that you are given a binary value. Like for example, they can say A is 65, for example, and they may ask you that tell the binary for capital F or capital H. And do not get confused. Once you are given one value, then you can find the next one very easily just by moving further, and you can find the correct value. One more thing is these values are always in a set, like all the A capitals are together, all the smalls are together, all the digits are together. So this is what you need to know regarding the character set, the definition of character set, and the Unicode and ASCII code. Secondly is sound. And in this, what you need to know is the sampling rate and sampling resolution, the two terminologies, very the two definitions should be on your fingertips. Along with color depth, the number of bits per sample is called sample resolution, and sample rate is the number of sound samples taken per second. So these two definitions should be on your fingertips. You can see for yourself, the questions in the recent papers are asking you these definitions. So please be very clear about these definitions. Any questions? Okay, now moving to another thing is this is the analog representation. Like you can see for yourself, this is analog data. And the digital data is represented like this normally. Like this is your digital data representation, or when you talk about the analog is always like this, or this is in the waveform. So you may be asked a thing like that sound is analog or sound is in this form, waveform, and digital is in the form of zeros or ones, or it is shown in this manner. And definitely in a computer, the sound waves are stored as digital values, and they have to be converted using ADC, analog to digital converter. Next thing in this chapter that we should be very clear about is bitmap images or BMPs, and then another term is pixel. And what is a pixel? The small, like you can say, the smallest element of a picture, or the small part of picture is made up of, or you can say picture element. These are going to be the definition of pixels, and these pixels horizontally, vertically, height or widthwise form a talk about the resolution. Like you talk about the high resolution, low resolution images, it is all because of the number of pixels high multiplied by number of pixels wide. Another important thing that you need to know is the number of colors. Very simple. If I say I am using 1 bit per pixel, it means it can support two colors, a 0 or a 1. If I say I'm using 2 bits per pixel, it means it can support two colors. And the formula is so simple. 2 power 2. 2 power 2 means the number of pixels is going to be like the number of pixels will be 2 power the number of pixels. If it's two colors, it means four possible values. If it's three colors, it means eight possible values. Again, you can see 2 power 3. 2 power 3 means eight possible values. Similarly, if I say there are 8 bits, it means it can support up to 256 colors. And when it comes to the you can say the true colors, which are a combination of RGB, then it will be representing 16.7 million colors, because it will be 2 to the power 24, and that is quite a huge value. And that is why what we see, the different shades of color, are all possible because of this. See, this is your RGB, red, green, blue combination. The thing that we have talked about earlier also, this RGB is all happening because of this 2 to the power 24, and that is nearly 16.7 million colors. Now, in the terminology that you need to be very clear about is color depth, and that is the number of possible colors. The number of bits to use to represent the color is called the color depth. Sample rate, sample resolution, color depth. And another term is image resolution or screen resolution. Image resolution means if you have, maybe this is my screen and this screen has maybe one picture. So this picture's resolution will be called image resolution, and this is the complete screen resolution, and this definitely will be definitely is supposed to be bigger than the images, because images are going to be smaller, are considered to be smaller than the screen. Like that is what you need to know. Now, next very important thing is storage, data storage, and file compression. And for that, remember the sequence: kibibyte, mebibyte, gigabyte, tebibyte, pebibyte, next byte. When you are going from here to here, what you need to do, and when you are going from here to here, what you need to do. And the thing is, when you talk about kibi, it is going to be 1024, and kibi, mebi, gibi, they all are dealing with multiples of 1024. And when it comes to mega or kilobyte, megabyte, gigabyte, terabyte, it is multiples of 1000. So if you get a question regarding the conversion, so you need to be very clear that are they asking with respect to megabyte or mebibyte. So be very clear. That is why the best thing to do is underline. In your paper, like this one, I've seen that a number of students, what they do is they underline the keywords in the question paper so that they're not making any mistake at all. Now, moving to the calculation of file size, you need to know the formula. Very simple. First one is the calculation of image file. The simple formula is you need to know the image resolution, that is number of pixels horizontally and vertically multiplied by color depth. Now, that is the simple formula. If they ask you to convert it to maybe kibibyte, what you need to do is, see, this is your again, a sincere advice. When you are given a question like this, do not go for multiplication at all. Like, okay, now just let me show you. Let me show you the working here. If, for example, I was given a question like this, what I will do, I'll write down in the first stage, I write down the values 1024 multiply by 1080. This is what I wrote because of the resolution. After that, what am I doing? I'm supposed to write down the color depth, that is 32 bits. This is my beginning. I'm done with this. I'll not do any sort of calculations right now. Please be cautious. I'll simply go for what? I'll simply go for the division. If they ask me to convert it to maybe just, okay, now just telling you the stages. If they ask me to convert it to bytes, I'll simply divide it by 8. That's all. I'll not do anything else. If they say convert it to kibibyte, I'll simply do one more and that is I'll go for 1024 again. If they say convert it to maybe bytes, I'll go for one more and I'll say 1024 like this. Please be very clear. Children, this is what the students, very good students also, they make a mistake, make mistake. They keep on doing the multiplications and that results in two problems. One is the wastage of their time, important time, and secondly, still the answer may be incorrect. So why not leave it here and then you can simply go for the cancellation, isn't it? Isn't it easy? Always apply the same. You simply write down the formula, resolution, multiply by color then, and then if they say convert it to whatever, like even they say they convert it to gigabytes, you will do one more division by 1024. And that is all. And then you can go for further for, then you can simply cancel out here so easily. You can simply see 8 and 32 are cancelled out. 8 times 1 is 8 and 8 times 4 is 32. 1024 and 1024 are cancelled out. And then if this is not cancelled out, perfect. No problem. You can go for cancellation with twos and or maybe four or something like that. So at least you are safe. You're not making a mistake at all. So my main objective is just to be very clear about that. How can I score the marks and how can I lose my marks? This is the formula. Okay, now another question that can come in the papers regarding the file size calculation for your sound file. And sound file is simple. This is the formula. Sample rate in hertz multiplied by sample resolution in bits multiplied by length of sample in seconds. Again, the same thing. The question always carries out the values very clearly. They mention it is sample rate or sample resolution and the number of length of sample should be in seconds. If it's already in seconds, that's good. But if it is not, then you need to perform the calculations like this, the way it is shown here in the question. That is like if it is 60 minutes. So 60 minutes has to be converted to seconds by multiplying 60 by 60. And then again, the same thing you will do here. Go for the same. They are asking you to convert it to bytes or to megabytes or kibibytes, then do it in the same manner. Division by 8 to convert it from bits to bytes. Another division by 1024 to convert it from to bytes to kibibytes. Like this is what is the main thing. You need to be very clear about. This is kibi. And then next one you're doing is your maybe. Just so simple. Do not make any mistake at all. And rather than making a mistake, it's better if you do it this way. Okay, fine. Maybe move ahead. Now, this is something which is sometimes making students confused. That is why I suggest the students to do it this way always. And then compression. Again, very important, very simple topic. Very quickly, recapping it. First thing that you need to know is what is compression. Reducing the size of the file. Why we reduce it? You can see reducing so that it is going to be streamed easily. Uploading and downloading time is going to be shorter and it will be reducing the bandwidth. And most important thing, it will be saving the storage space. Most important is the saving of the storage space. Because when you are reducing the file sizes, then it will be resulting in more data saved in lesser spaces. Compression techniques are basically two, lossy and lossless, as the name implies no loss of data. When do we go for lossless? When loss of data is disastrous. As in the case of your, like normally, I have made a Word file for you people, maybe some notes. I need to give it to you and you should be getting exactly in the same manner. It should be lossless compression. Spreadsheet files, Word files, presentation files, program files, they all should undergo lossless compression because their loss of data is disastrous. Although the data will still be like, because we can reconstruct the data, we can get the exactly same data back. But with lossy, there is loss of data that you are going to lose the data and that may result in complete loss of some data. As you can see, it is going to eliminate unnecessary data. Unnecessary, maybe they are going to reduce certain sounds which are beyond the human ears can say capacity. Maybe if two sounds are played together, then the louder sound is kept and the lower sound is eliminated. That is how lossy compression works. And lossy compression formats you need to know are MP3, MP4, and JPEG. And you can see MP3 is reducing the music file by about 90%. Imagine 90% reduction means only 10% is there, and still the quality is good enough for your ears. Some quality of the sound is lost, but most of it is retained, removes sounds outside human ear range, eliminates softer sounds, as I said right now. MP4 is your video, and JPEG is the pictures or the images. So all these you can see human eyes cannot detect the differences in the color. Like for example, if the shades of color are there, I may not my eye may not detect maybe the shades of red, because we are not Allah Ta'ala has not made our eyes like that. So that is what is going to result in your lossy compression, means the data will never be recovered. Okay, I'll give you an example, very simple example of the chemical reaction, just to make you understand. The chemical reaction, if they happen, you cannot get the same thing back. Similarly, in lossy file compression, the file once compressed, you cannot get the original file back. It is all gone. But with lossless, you can get, and the important algorithm or the important thing that we need to know is RLE. You know the full form? Excellent. You don't know the full form? Still write RLE. That's perfectly okay. It's an example of lossless compression. And here what happens, just be very, very clear. It is going to reduce the size of a string of adjacent identical data. This is going to give you complete 1 mark, because sometimes they do ask about about RLE, and for that you need to remember it's going to work on a string of adjacent identical. And how it is going to do the work? It is going to do this in by encoding in two values. The first value will represent the number of identical items. How many times is it occurring? Its occurrence. And next value will be the value. Like for example, if it's an ASCII value, the ASCII value will be there. If it's a picture, then it will be storing that picture value. And just an example for you to understand, this is one value, like A's, then B's, then C, D, C, D, and E. What see, you can see again a string of adjacent identical data. So what is done? Just an indication of a flag indicating that the value has been repeated, and then 8 times 97, which is the ASCII value for small a. Then 255 again showing a repetition or a flag. 10 times 98, which is B, is there. CD is not duplicated, is not repeated. That's why it is written separately, like 9900, 9900, 9900 for the ASCII values. And then E is again repetition. That is why 255 indicating a flag. And 8 times 101, that is the ASCII value for E. And that is how you can see it is going to result in some sort of, can say, file being compressed. Using early with images, did they here the image is a black and white. Here the image is a complete colored image. You can even go with a black and white image. So black and white image is going to do in the same manner that it will be just counting that how many times is the white color or how many times is the black color. But just with this, you can see for yourself, the beginning is with 2 black, and the black color has the value of 000. That's why 2 is representing the number of times and 000 is indicating the color code. Similarly, next one is green, 4 greens. That's why 4 times the green color, that is 0 to 550. That is RGB. Okay. 255 is indicating the green color here. Then you can see, then now 1, 2, 3 black colors. The 1, 2, 3 black colors are here. So in this manner, you can even count yourselves, and you can see for yourselves that the number of original was much, much bigger, because it's an 8 by 8 square, and each square is going to come in 3 bytes. So 8 by 8 by 3 will make 192 bytes. But once you have compressed the file, it will be now storing only 92 values, means nearly 52% reduction. So that is good enough for the human eye, or the human for the human eye to understand, or human find. So this is how the compression is being done. So RLE is one format that you need to know for the lossless compression. And again, sample questions and answers are here. Again, the same tips. Very important tip is when it comes to explanation, then what they want you to write there. Explanation questions, how they want you to write. So this file is with you, the explanations are with you, questions are with you, past papers are with you. Do it, practice it, and then come back with any questions if you have, like drawback of using lossy compression, drawback of using lossless compression. And again, the same, a camera detector is an area of this one. So how to attempt these questions, you can do them, practice them, and inshallah, it will be all okay. Again, although this child has done it, but again, I'll not recommend you to do it this way. I'll not go for the multiplication process at all. because it may result in a wrong answer. Again, the choice is yours. Hope that this chapter number one's revision is completely clear, whatever we have done today. So, inshallah, we are going to meet again with another chapter, inshallah, very soon. So, till that time, take care of yourselves and your loved ones. Allah bless you. May Allah Hafiz.